Bonjour and good afternoon. Welcome to WASA Distance Education Center and PLAR Science. So we're into week 8 of term 2B. This is our 14th class of PLAR Science, and that means that we only have, after this class, we only have 3 more classes left. So we're into nearing the end of term 2B. Also, things that are coming up, we have the graduation on June 18th. Oops. So June 18th, that is on a Tuesday. Here in Sioux Lookout, it will be at the Legion. So make sure that if you are interested in attending the graduation ceremonies, that you make a note of that date. So Tuesday, June 18th is the WASA graduation. Students who are interested in signing up for term 3, make sure that you send an application form to WASA, or you can send it to your local DEC or directly to Michelle. Okay, she's one of our counselors. If you have any questions regarding PLAR applications or PLAR assessments, you can contact Candace. The term 2B draws, as I said, is nearing an end to the end now. So we will have 2 student draws, one for students who earned a credit, and then we will also have one for students who submit work. So make sure that you're submitting your work to your teacher so that it can be entered into the draw. So remember, you don't have to complete all of the lessons all at one time. You can submit as you complete a lesson. Students working on more than one course will have their names entered for each subject they submit work for. So the courses for the summer term, it starts June 24th until August 23rd. We have a group of English courses, NBE 3C, ENG 3E, the College English 4C, and University English 4U, and of course the Ontario Secondary Literacy course, OLC 4O. Under the math, we have Workplace, MEL 3E, College Math, MBF 3C, another College Math, which is the grade 12, MAP 4C, and the grade 12 Technology College Math is MCT 4C. Under the Sciences, we have SNC 2P, SVN 3E is the grade 11 Workplace, SBI 3C is the grade 11 College Biology, SCH 4C is the College Chemistry, and the grade 12 University Biology is SBI 4U. Students interested in working or doing co-op can sign up for DCO 3O, and students needing the history courses, CHC 2P, which is the grade 10 Applied History, and the NBV 3E is the Workplace Native Studies. So if you're interested in signing up for those courses, remember that's the summer term, June 24th to August 23rd. You have 9 weeks. You can sign up by contacting WASA or using our online application form. Contact your teacher if you're having any problems with your key questions using our office number, fax number, email. You can also contact me using my Facebook Messenger. And remember, our office hours schedule is available from your DEC, or you can simply call the office to find out. To submit your work, have your DEC fax, scan, email to studentwork@nnec.on.ca. Make sure that you CC to the teacher that's marking your work. You can also do it yourself by using your Notes app on your smartphone. Just scan, email it. You can also send a picture through Messenger, or you can drop it off at our WASA office. To support you in completing your key questions, you can also watch our classes on YouTube. Go to playlists. So once you go to our profile, mine is J. Mercer WASA, Bonnie's is B. Osmond WASA. Go to the playlist where you see home videos, playlists, community, about. So go to the playlist section. You will see that we have created a playlist for each of the PLAR components. So if you're working ahead in PLAR Science, if you're working on lesson 5, then go to the PLAR Science 1B, 20, 23, 24. All the PLAR Science classes are there already. If you don't have Wi-Fi or internet, you can also request a USB of classes. Remember, you can view these on your laptop, your television, using Xbox or PlayStation. Just remember to open the class where you might be needing help with. So if you need help with key question 36, then you will open the PLAR Science lesson 2, key questions 35 to 40. So it's showing here on our course calendar, and remember, this is just a suggested course calendar to make sure that you complete all the key questions. So we are looking at lesson 4 physics. We will be starting with lesson 5 this week, and then I will go over the culminating activity for PLAR Science next week. The evaluation, that means that you complete each lesson, and there are support questions and key questions for each lesson. A total of 80 key questions are in lessons 1 to 5. Once you complete that, then you can do the culminating activity. Remember, you need 50% or over to pass it. Your DEC or myself will give you the culminating activity to complete. Make sure that once you receive it, you start working on it right away and then return it to me. That's the only way you will get your equivalent credit. You need to return the culminating activity to your teacher to have it marked. From our last class, so I'm showing you here now the teacher comments or marks to students. Again, use this as your checklist so you know which key questions you have completed. We did as far as key question 69 last Thursday. We have 2 more key questions left to do for lesson 4, and there are only, I believe, 9 key questions for lesson 5, and then we're done. For this afternoon, we will look at, so learning goals. I can describe the similarities and differences between current and static electricity. Page 9, what is electric current? Some common electrical symbols. Dry cells on page 10, and then we have current, electricity, amperes, volts, and ohms on page 12. Okay, so those are our last topics for lesson 4. So a quick review here. We said electrostatics are also known as static electricity. Static electricity is electrical charges or electrons that are at rest. That means not moving. We also looked at 3 different types of charged objects. We said objects are positive, they can be negative or neutral. So that's what that means by 3 different types of charged objects. We also looked at law of static charges, or the law of electrostatics. We said that unlike charges attract, that's the first law. So if you have a positive object and a negative object, they will attract, because unlike charges attract. Second law states that like charges repel. So if you have a negative object and another negative object beside each other, then they will repel. Same thing if you have a positive object beside a positive object, then they will repel. Okay, like charges repel. The third law is neutrally charged objects are attracted to charged objects. So what that means is if you have a positively charged object, so you see here I wrote plus, 0 means, or the O means no charge. So if you put a positively charged object to a neutral object, they will attract. Same thing if you put a negative charged object in a neutral object, they will attract. So bottom line is if the charges are alike, then they will be attracted to each other. We also looked at two terms, conductors. These are metals, or such as metals. These are substances that allow charges to move freely through the object. So gold, copper, steel are examples of conductors. Insulators, we said, were nonmetals. These are substances that do not allow charges to move freely through the object. So rubber, glass, oil, these are examples of insulators. Finally, we looked at lightning, which is a spark that jumps from cloud to cloud or from cloud to earth. And we said that this is a form of electricity, and it happens when negative and positive charges of electricity in clouds get together. So it's caused by static electricity that builds up in the clouds. Lightning bolts are a good example of a very large electrostatic spark. Okay, we will see more of that as we get into summer. So this is where we left off on Thursday. We looked at what is electric current, and I asked you to think of all the ways that you use electricity every day. Whether you wake up to an alarm clock or radio, or even if you use your phone, okay, as your alarm clock, it still requires electricity because you have to charge it. You may also use an electric toothbrush, or before you head off to work or school, you may make your breakfast. So you're using appliances, whether you're using a toaster or the oven or the stove to make your breakfast. You might also watch television, or if you're using your iPad, or if you get ready and you need to dry your hair because you had a shower, then you are also using a hair dryer, and you're probably using electricity to get your hair dryer working. Also, almost every place you go, you find electrical lighting. So electricity plays a major part in our everyday lives. We depend on it for nearly everything we do. You can list your favorite activities below and just determine if electricity was used. So for example, you have activity on the left hand side, the equipment that you used in the middle, and then on the right hand side you determine whether electricity was used or not. So the activity on the left hand side is reading a book. The equipment you use is a light bulb. And did that require electricity? Yes. Second activity, played video games, equipment use, gaming system or television. Did that require electricity? So yes. So you would just write down some examples or activities, then the equipment you used, and then you tell me whether you used electricity or not for this activity. So let's say if you wrote cooking, maybe that's the activity that you participated in. The equipment you used was the oven. Electricity used, yes. Maybe you exercised and you used the treadmill, and was electricity used? You might write down yes. So that's all that simple exercise asks you to do. Just lets you or gives you an idea how much you rely on electricity. And of course, answers will vary depending on each student or depending on the activities that you participated in. So what is electric current? Well, electric current, if you turn to page 9, this is the electricity that works all your electrical appliances. It requires the flow of electrons. So electrons are the parts of the atom that have a negative charge. And electrons move along a path, and that path is called a circuit. While the electrons are moving, the circuit is complete or closed. So if the electrons stop moving, the circuit is complete, which means it's open, and the electricity stops. So for example, if you go in the room and you flip the switch, that means you are closing that circuit. So you will turn on the lights. When you flip that switch, so when you leave the room, you flip the switch, now you have an open circuit. That means the electricity stops and the light is turned off. Some of our electricity comes from batteries. Now, batteries are like those used for flashlights. These are called dry cells. But most of our electricity comes from machines called generators. Look at the picture on the bottom of the slide. You can see a generator, then you have the powerhouse. It gives electricity to the power lines, and then it gives electricity or provides electricity to the people in that city or that area. Here are some common electrical symbols. You don't have to memorize these, but this is something that you might see in your home. So if you see that symbol with the lines, long, short, and so on, that shows battery or DC power supply. A line tells you that's a wire. There's a dot, that's a wire connection. Then you see the line open with the dots, that tells you that's a switch. A sign with the V on it says voltmeter, A says amperemeter, G says galvanometer, and so on. Okay, but these are just common electrical symbols. Continuing with dry cells, dry cell changes chemical energy to electric energy. And dry cells come in many different sizes and strengths. The parts of a dry cell, so as we said, a dry cell changes chemical energy to electric energy, and it comes in different sizes. So if you're away from home, there may not be electric outlets around. Let's say you decided to go camping and you want your radio. So where do you get electricity to run your radio or your flashlight? You would need dry cells, because dry cells and batteries store electricity. Okay, it's portable. If you have a dry cell or a battery, that means you can take electric energy with you wherever you go. Continuing with dry cells, these are not really dry because the outside of one kind of dry cell is made of metal zinc. So you're looking at the cross section so you can see the inside of a dry cell. Inside the cell is a paste of chemicals. So the chemicals react with the zinc, which loses some electrons. As the chemicals react, a flow of electrons forms an electric current. So this way, chemical energy becomes electric energy. There are two posts called terminals in a dry cell. One terminal is positive, and you can see that there's a plus, and then one terminal is negative, and the negative shows you a minus. A wire can be put between the terminals to make a circuit. You can make something that uses electricity, such as a light bulb, as a part of the circuit. So the flow of electric current will light the bulb. So you have a battery working, two or more working dry cells together. A battery can give you more volts, okay, than a dry cell, meaning that the more cells in a battery, the more volts it can give. A battery is used in most cars. The battery itself does not make the car run, but it does need to make it start. Two types of current electricity. One is direct current, and this happens when the electrons flow in the same direction all the time. So batteries produce direct current electricity. Some examples of direct current usage: MP3 players, radios, electricity in cars, basically anywhere where you use a battery for power. This is the type of electricity used in most electronics we have today. Remember, direct means the current only flows in one direction. Just like when you have a direct flight, that means there's no stopping, you just go one way. Okay, the opposite of that is alternating current, and this happens when the electron flow changes directions. So the electric outlets in your house provide alternating current electricity. Common form of electricity from power plant to home or office. Its direction is reversed 60 times per second in the US and 50 times in Europe. Some examples of alternating current usage. In the kitchen, you have your stoves, your ovens, your mixers, so most of your appliances, computers, so the plug, lights in the house, home air conditioners, they all use alternating current. So you can see that alternating current, the flow of electricity flows this way first, and then it alternates, so it turns around and then flows the other way. Okay, more terms to look at in electricity. Let's look at amperes, volts, and ohms. So how do you measure temperature? Well, when we measure temperature, we measure it in degrees. When you're measuring time, we're measuring it in minutes, hours, days, and so on. If you're measuring length, weight, okay, what do you use for using those different units? So same thing with electricity. There are special units to measure electricity. The three most important are amperes, volts, and ohms. So first one is amperes. This is the size of an electric current, and it depends on how many electrons pass a point in a circuit every second. So if you have a greater number of electrons, the larger the current. Fewer electrons mean a smaller current. So the size of an electric current is measured in amperes. So we can say that ampere is another name for electric current. Volts, well, nothing moves by itself. You need a force to make something move. Same thing with electricity. Electricity needs a force to move it. So electrons, or the flow of electricity, move in a circuit because a force pushes them. So the name for the force, or pressure that pushes electrons is called electromotive force, or EMF. So the strength of the EMF is measured in volts. Finally, the third one is ohms. So ohms measure the resistance to the flow of electrons. You know that a wire resists the flow of electrons, so the amount of resistance is measured in ohms. So we're going to look at these three terms closely. And here's a great way to show it is think of it as a hose, and then like a gardening hose and water. So the connection between amps, volts, and ohms, when one changes, there must be a change in one or both of the others. There is a rule for figuring these changes. It's called Ohm's law. So what you have here is a picture of volt, amp, and ohm. So volt is the one that's pushing amp, and then ohm is at the top there, and he's trying to close off the entry where amp is trying to get through. So think of volt as the pressure of the water. So think about the hose and then the water coming out. The volt is the pressure of the water. So if the pressure is high, you will get more water coming out. If the pressure is low, that means there's less water coming out. So volt, you can make the flow go farther. Amps is the actual current flow, so it's the water. So pressure or hose diameter equals the total water flow. So if the pressure or the hose diameter is small, then that will interfere with the total water flow. Ohms is the resistance. So think of this as the diameter of the garden hose. It's easier to get more water through a bigger hose than a smaller one. Or let's say if your hose is twisted, so sometimes you're dragging that hose to water your plants and it gets twisted, so you get a kink there, then what happens is that there's less water flow and you can't water your plants properly. Okay, next up is using electricity safely. So machines that run by electricity make life easier, but any machine or tool run by electricity must be used safely because electricity can pose a danger. Okay, people should take care when using electric outlets. Remember, outlets are meant for plugging in electric cords only. Never put anything else into an electric outlet, because an object put into an outlet can carry electricity. So think about the insulator and conductor. So electricity can burn the hand of the person holding the object. When cleaning or fixing an appliance, be sure to pull the plug out of the outlet. An appliance that is still plugged can still have electricity in it, so it can still give you a shock. Water is a good conductor of electricity, so keep electric appliances away from water. So for example, you should never wash or bathe with a hairdryer near you. If the appliance fell into the water, the electric shock could kill you instantly. Okay, here's a picture of a child, and she is carrying a screwdriver. Okay, and at the end of the screwdriver is metal, so that's a conductor, and now she's trying to push it into the outlet there. Okay, so that's not safe. You can actually buy those electric outlet plugs, okay, to baby proof, okay, to make sure that nothing like that happens, or child proof your electric outlets to make sure that children doesn't put anything, or your young child doesn't put anything in there. Okay, other examples: never touch anything electrical with wet hands or while standing in water. We said Keep metal objects such as silverware away from plugs. You pull by the plug, not by the cord, because if you pull by the cord, you can actually fray, okay, the cord. So pull from the plug. Don't use frayed or broken cords or plugs that are missing a prong. Might get a shock. Don't overload sockets, and don't run cords under rugs or furniture. Okay, so let's do the last two key questions. Remember, in your key questions for lesson 4, you have key questions 64 to 71. You should try the support questions. Those are there for practice, answers at the end of this lesson, which you don't have to submit for marking. You don't need to Google any or do a search on the internet for any of the answers. They're in your book. Okay, they're mostly hand questions, meaning you can put your hand or your finger on the answer. The key questions, like I said, can be faxed, or you can email them, or you can take a picture and send through Messenger. Remember to send to student work and then CC to the teacher that's marking your work. Okay, we did key questions 64 to 69. We have still to do 67. What you have to do here is, in your own words, explain the following terms. So like I said, you don't have to do a search on the internet. They are in your book. EMF, we also know that as electromotive force. Okay, tell me what it means. Electric current, volts, the word battery, amperes, conductor, ohms, insulator, dry cell, and alternating current. Okay, you will find these in your lesson 4 lesson book. So if we go over our key question topics, we did key question 64, 65 regarding the 3 laws of electrostatic. We did the types of charges, key question 66. So this is what we just did now, key question 67, explanation of terms, again in your own words. We did attraction, repulsion, or neither, key question 68. Then we talked about Benjamin Franklin and lightning, which is key question 69. Okay, so let's do key questions 70 and 71. So key question 70 says, look at the pictures and answer the questions that follow. All it's asking you are 3 questions. Is the circuit complete or incomplete? Are electrons moving? And does the light bulb light up? Remember, I talked about an open circuit. So if you have an open circuit, there's a loop with a break or gap. And an open circuit is a gap that stops the flow of electric current. So when you turn on or you flip the switch in the room, so say the room is dark and you flip the switch, that means you have closed the circuit. And what happens is the light will come on. When you flip the switch down, then the circuit is open and it stops the flow of electric current. So the room is dark again. So let's look at this one. So is the circuit complete or incomplete? Now look at the light bulb. If you're not sure if the bulb is lit or not, look at the second picture. The second picture shows the lines that indicate that the bulb is lit. So we know in 70A, is the circuit complete or incomplete? It's incomplete. Electrons moving. So when it's not complete, then that means the electrons are not moving. Does the light bulb light up? The answer is no. In key question 71, it's asking you, look at the diagram below and answer the following questions. So same questions, is this circuit complete or incomplete? So what you have to do is look at that lever. There is the switch. Notice it's up and the switch here is down. So is the circuit complete or incomplete? That one is complete. Electrons moving? Well, we see that the light is lit. So yes. Does the light bulb light up? The answer is yes. So it tells you that closed circuit, a loop in which all parts are connected. And a closed circuit allows the current to flow through the circuit, which means you have a light. Okay, so we can look at our next topic, which is lesson 5. So lesson 5 is environmental science. And in your lesson 5, you have also the key questions. So remember, the key questions are still at the end of your end of the lesson. Same format. Your support questions are for practice, so you can try those, but you don't need to submit them for marking because the answers are at the end of the lesson. Learning goals. What will you learn by doing lesson 5? I can describe the different components of an ecosystem, and I can explain the dangers of global warming. Okay, first of all, let's look at what is environmental science. Well, environmental science is an interdisciplinary study of how the earth works, how we interact with the earth, and how to deal with environmental problems. So the study of how humans interact with their environment. When you look at our environment, so that's everything that surrounds us, both natural and man-made. So for example, think of an example of natural, and then an example of man-made in the environment. So natural could be the ocean. It's natural. Trees. Man-made can be bridges. Okay, roads, buildings. So these are all man-made. So we have for natural, ocean, trees. There's air in our environment, so that's natural, and so on. Okay, environmental science, like I said, is an interdisciplinary field. It includes many fields like natural sciences and the social sciences. It also encompasses agriculture, chemistry, physics, economics, sociology, psychology, biology, law, ethics, engineering, politics, philosophy, computers, earth sciences. So lots of interdisciplinary fields under environmental science. The first term that we will look at, or definition, is the word ecology. So ecology can be defined as the study of the interactions of organisms with their environment and with each other. Okay, so interaction, how we interact or how we get along with the other organisms. It involves concepts from many disciplines, including biology, chemistry, and geography. Okay, so that's the word ecology. Ecologists, okay, that's a noun, are people who study these relationships and interactions, and they're particularly interested in the life processes. Remember, we looked at that in lesson 2. For example, reproduction is a life process, nutrition, reproduction, growth, movement, those are life processes. Interactions and adaptations of different organisms. Okay, they're also interested in the movement of materials and energy through living communities, how ecosystems develop and change over time, and how biodiversity works in different environments. So what you're seeing here is that ecology is a branch of science that also studies basically how human beings interact with the environment. Okay, that's your basic definition. And ecologists, again, basic definition, a scientist who studies how organisms interact with their habitats. So it could be as simple as just studying the house or environment in which we live. Okay, so that's a habitat. That's the environment in which the species lives. Ecology, like we said, is the study of interactions between non-living and living components in the environment, and that will include light, water, wind, nutrients in soil, heat, solar radiation, atmosphere, etc. Living organisms could be the plants, animals, and the microorganisms in soils. Okay, next up is ecosystem. So a community of many different living organisms that interact with non-living parts of their environment. So it could be the air, water, or soil. It is made up of biotic components, and biotic components of an ecosystem are the living things. So remember, biotic, so living things, such as plants, animals, insects, bacteria, and fungi. And then the word abiotic means these are the components of an ecosystem that are non-living. Okay, so make sure that you know the difference between biotic, so that one is living components, and abiotic are non-living components in the environment. So it could be temperature, light or darkness, water, air, and minerals in the soil. So here you have an ecosystem with a community of living organisms interacting with each other and their non-living environment. So here we have a pond. And what we're going to do here is let's look at all the living things, okay, in that picture, and then let's look at all the non-living things. So remember, living, biotic, and non-living, abiotic. Okay, so when we do this exercise, then you will see how you will need to do this for one of your key questions. So one of your key questions, key question 73, is where you have to list 4 biotic and 4 abiotic factors. Okay, so keep this in mind for key question number 73. So this is a pond. So let's look at biotic factors in the pond. So we see animals. So for example, you can see the deer, the frog, the raccoon, the turtle, there's fish, okay, there's insects. So biotic factors, let's say insects. We don't have to list all the animals, so we just say animals because we know there's deer and raccoon, frogs, turtles, We also see plants. Okay, these are parts of biotic. Fish also is part of biotic. And then we also have in a pond algae or algae. And then let's look at abiotic. So remember abiotic. Now we're looking at non-living factors. So again, look at the pond. Okay, water is abiotic. So that's a non-living factor in the pond. We have, well, there's grass there, so that means there's soil. That's abiotic. There's rocks. Okay, sunlight, temperature, these are all abiotic. So again, keep this in mind for your key question 73 because you have to look at biotic and abiotic factors in two types of ecosystem. We have one for lake and one for forest. So this one is a pond, so very similar to a lake. So it's all here. It says an ecosystem is a community of living organisms interacting with each other in their non-living environment. So biotic and abiotic. All living things, plants, animals, and bacteria. Non-living things, the sun, rocks, and soil. Okay, before we go, what I want you to do is look at in the biotic components, we are looking at the living things that shape an ecosystem. And we said it would include organisms, okay, their presence, parts, interaction, and waste. So there's some factors like parasitism, disease, and predation. That means you have one animal eating another. These would also be classified as biotic factors. So when you have your different categories of biotic components or organisms, these include producers. Okay, now producers or autotrophs, these are plants that convert the light energy from the sun into food. So remember, animals cannot make their own food, plants can. We have to depend on producers to provide us with food. So producers, they make food through photosynthesis. Okay, they use sunlight, carbon dioxide, water, oxygen, and glucose. Okay, so the next one, consumers, or what's known as heterotrophs. These are animals that depend upon plants and other animals for food. Okay, so that includes us. Hetero means others. Troph means nutrition. Cannot make their own food. They must eat other living organisms. Okay, and finally we have decomposers or detritivores. Fungi and bacteria break down chemicals from dead animals and plants into simpler forms that can be reused. So what they do is they eat dead stuff like dead plants, dead animals, and animal waste. There's many types, bacteria, fungi, animals like insects, worms, etc. Most of them thrive in moist environments. So you can see here there's the food chain. You have your producer, and we'll look at this more closely. Then you have your consumers, and then you have your decomposers. Okay, they eat the dead stuff, whether it's dead plants, animals, or waste. Okay, that's it. That's all we're going to do for today. On Wednesday, we will continue with page 4, looking at biotic components and abiotic components. Okay, thank you for joining me. Miigwech.